Hello everybody. Today we're going to learn about graphing square root functions. It's pretty similar to graphing any function. We can make an XY chart here. So let's make it blue actually. So XY. I'm going to choose X values that are perfect squares to make it easier. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Okay, so we can just kind of choose values that are going to make this easier. We're not using negatives this time because you can't have the square root of a negative number. So that gives us less things to graph. So 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. So you can see it's kind of loses altitude as it goes. It's never going to go back down. It's always going to kind of slightly go up, but it does definitely flatten out. Sorry, that's supposed to cross through that point there. So there's the parent function of square root graphing. So y equals square root of x. Looks like that. Here's an arrow. Goes on forever. When we're talking about there can't be any negative numbers, that doesn't mean x itself cannot be negative sometimes. It's just whatever is under the square root symbol cannot be negative. So to figure out the domain, which is all the possible x values, we just set that square root, 3x minus 9, actually we don't need the square root part, but the 3x minus 9 part has to be greater than or equal to 0, meaning non-negative. So once we solve this, we can figure out what the domain of x is, or what the domain of the square root function is. So in this case, x has to be greater than or equal to 3. In the case of y equals square root of x, x has to be greater than or equal to 0. So that domain is going to change depending on what kind of stuff is under the root. So let's say we were graphing something like this, and notice I've made the scale on the x-axis much smaller to accommodate some larger numbers. The y-axis I kept the same. Let me label that. So we have x and y. So let's make an xy chart. This one is green. So we're going to divide by 5 on all these. So if I, first of all, the square root of 0 is 0, divide by 5 is 0. The square root of 1 is 1. Divide by 5, that's 1/5. Square root of, again, we'll go to 4, is 2. 2 divided by 5, 2/5. So you can see why we need to go much larger on the x, because not a lot's happening down here with like 1 and 4 and 0. So we get up to, 9. Square root of 9 is 3, so we got 3/5. So not a lot's happening. But once you get up to like, let's say, well, 25, the square root of 25 is 5, and 1/5 of that would be 1. But if we get up to like 100, the square root of 100 is 10, and 1/5 of that is 2. So we do actually get to some whole numbers here. So to graph that, it's just 0, 0, 1/1/5 is pretty close to that. So I'm going to jump up to like 25/1. So 20, there's 30, so 25/1 would be like right here. 102 is like here. So you can see it kind of has that same feel. So that would look like that. Now, just like any other parent function, we can move the graph up and down. So I'm going to go ahead and copy this graph so we can make some adjustments to it. Oops, let's bring that down. Let's try that again. So get all that. We're going to copy that, bring it over to here, and paste it. Okay, so here was our parent function. And so if we have the same thing, so our parent function was y equals absolute value of x, which is the blue line, if we add 2 to that, all it does is move everything up 2. So if I were to copy this line, the blue line here, we're going to copy it, and then we're going to paste it, and that's not where it goes, but I just want to show you the same line. And I'm going to change the color to green to show that it's going to be the green one there. There we go. Let's get rid of that. Okay, so now we have the green version of this line, which is the y equals absolute value of, the square root of x plus 2. So here it's the same, and then if we just move it up 2, that's what happens when you add 2 to it. So if we were to add 4 to it, it would go up to there, or add 6, and so on. If we were to subtract, it would dip down like this. Okay, but since we added 2, it just changes it vertically by 2. And you can still make the XY chart, and you might have to if you don't have that parent function handy, but it's exactly the same thing, it's just higher up. Then we have, oops, that's just a extra slide. We can also do a horizontal translation. So let me paste that line there for a moment. And let's see, I'm going to make this red. Okay, and I'm also going to paste that initial graph we had. So let's copy that as well, and let's put it onto this. Oops, that's not what I wanted. Let's try that again. Okay, so we again have that original parent function graph, which was y equals square root of x, and so now we have this y equals square root of x plus 2. So what that is, it's actually going to be the same thing, but it's just going to be moved. In this case, when it's plus, we move it left h units. So whatever's being added, that's how far left it goes. So I don't have the left of the x-axis labeled, but essentially it's looking like this. It's moving over about two units. And as it flattens out, you can see it's going to get closer there. So that's how the graphing works. You can use an XY chart. You can translate the parent function, but that's pretty much it. Thanks for watching.